Hey, I'm Neto, developer advocate on the Actions on Google team, and I'm here today for one more Behind the Actions episode. And today we have a new guest. Hey, Daniel, how are you doing?
I'm doing well. How are you?
And Daniel is my teammate, so what do you do in our team?
So I'm a developer advocate here at Google, specifically on the Google Assistant and Actions on Google team, where I work a lot on various smart home and IoT related aspects.
So you can see he has a cool suit. He does a cool industry. So different. Kidding. So, okay, but what is this weird stuff here? What are they going to present to us today?
Absolutely. So this is a Raspberry Pi. It's actually a Google AIY Vision Kit, where we will be modifying this off-the-shelf device to enable Google Assistant controlling, to where you can give it various smart washing commands, like start my cycle, run cycle, turn it on and off, things like that.
Cool. So if, for example, I'm running late to catch my bus, and I forgot to start my washer machine, I could send some command and even from my shuttle say, hey, forgot start my laundry. So
Exactly. You know, part of the reason why I chose a smart washing machine today is because it's a little bit more complicated than just a smart light bulb, right? We still have the on-off you would have with a light bulb, but you also have things like modes and various other traits that you get exposed to when developing a smart washer.
Yeah, much more. It's a good fit for our Behind the Actions, right? We're gonna show some deep dive on this structure. But yeah, before we start, can you show us how it works?
Absolutely. So I have this already set up with my account. I have it set up with my Google account. All of my everything's already been deployed. And so what I'm going to do is actually talk to Google Assistant. Hey Google, turn on my washer.
Sure, turning the washer on.
Oh, you can see here the LED. Okay, great.
So blue means it's on. Now, if I start it, it'll actually start flashing various colors. Hey Google, start my washer.
You got it, starting the washer.
So now it's like the washing cycle is running, right?
Exactly. So that's a various cycle that you can start on a washing machine. Now, there's also other toggles. It's another type of trait that you can have on a smart device.
Okay.
Now, if I turn that on, hey Google, turn on turbo for my washer.
You got it, turning on turbo on the washer.
And so now turbo's on the washer, and so that's a various toggle that you can control through voice as well. And ultimately you can turn it off as well. Turn off my washer.
You got it, turning off the washer.
Cool. So what's happening here is like Google Assistant is handling all the things you said, calling an API at some point and sending the command to here, right?
Exactly.
It's a very high level overview. Can you explain some details how all this stuff is going back and forth and working?
Definitely. So at a high level, you can think of it as cloud-to-cloud communication.
Okay.
So the first element is just me, the user, saying a command, turn on my washer. Google Assistant takes that audio, transcribes it into text, and then applies natural language understanding, and ultimately outputs a structured JSON response to your cloud service.
Cool.
So think of like Philips Hue, for example, right? If you buy a Philips Hue light bulb, that will have its own application, its own cloud service that you can use to control those lights.
And you have to log in your own account, make all the process to assure that you are not turning off your neighborhood lamp, so something like that, right?
Exactly. And so in this case, Google Assistant communicates with their cloud service, right? So if you're turning on and off a Philips Hue light bulb, Google Assistant communicates with Philips Hue.
Okay. So similar that we have for the regular action, what we call the webhook, we can imagine it's the same high-level architecture. So I have a webhook where Google will call this webhook to send the commands, right?
Exactly right. And so what I've developed here today is my own cloud service that accepts these structured JSON responses and then communicates that information down to the device.
Okay.
In this case, I'm using Firebase as my transport down to the device, and this is looking at various database states that it's subscribed to.
Okay, cool. So basically, what you need is you need to set up your webhook, your environment, your cloud serverless or whatever you are using. and enable this to receive commands through JSON from the Google Home, right? For the Google Assistant. And there is one word you said, like HomeGraph.
Yeah.
What is HomeGraph? What does it mean?
Yeah, so the HomeGraph is a very critical element with smart home.
Okay.
It houses all of the contextual information about you, your devices, and your home.
Okay.
So think of, you might have 5 or 6 different smart light bulbs in your house.
Sure.
You might have a smart washer. You might have a fan. You might have
microwave
or a thermometer somewhere, right?
Okay.
A thermostat. All of that information is stored in the HomeGraph. So when you say a command, turn on all the lights in my kitchen, Google Assistant is querying the HomeGraph to get a list of all the lights that are actually in your kitchen, right?
Cool.
If you say, for example, dim the lights just a little bit, right? It's going to query and see what the current state of the dimming is, and then dim it just a little bit.
And this is important because, for example, at my house, I have me and my wife. So, and for example, I was the only one that configured the lights and set it up on my assistant. But she's also is able to turn on and turn off because since she belongs to the same home in my configuration, she has access to the same home graph, right?
As long as you share.
You can share, of course, you have to authorize.
Right. Exactly. And, it's important to note, too, this is a very critical aspect, is that a smart home action that uses the HomeGraph is distinctly different from a conversational action.
Yeah, this is my next question. Okay, great.
And so with a conversational action, you have to provide various training phrases, and you can create any custom intent that you want for your agent.
You don't need to do this.
That's exactly right. So for smart home, we have a fixed set of intents.
Nice.
Which include things like onSync, onQuery, onExecute, and onDisconnect.
Okay.
These are the various commands that you can give to a cloud service to do various things with devices.
One of the commands you said was turbo, right? And it's because your washer supports the turbo mode. If I set to change to another program, I don't need to train my action, my home automation action to know my different modes, not because you understand all the phrase and you send the parameters, and then you handle these parameters in your backend, right?
That's exactly right. So when that's one of the beautiful aspects of smart home is that you as the developer define the capabilities of the device, right? So if we take the example of a smart light bulb, right? Most smart light bulbs that I know you can turn on and off, right? Some you can dim, and others you can also change the color.
The color, yeah.
Right? So these are 3 distinct different capabilities of a light bulb. Now, how do you define that so that Google Assistant can control those capabilities?
Cool.
We have a thing called device traits. We have a huge collection of different device traits that you can use and to define the capabilities of your device.
Okay, nice. So, okay, you said developer. As a developer, I'm excited. I want to build something to my homebrew system. And what are the requirements? What do I need to start developing for home automation with Google Assistant?
Yeah, so my personal favorite route to go is our smart home code lab that we have online.
Sure.
The biggest thing that you need is just a computer. You don't even have to have a physical device to get started. You can actually do it all virtually through the code lab. If you want, you can definitely have a Raspberry Pi or any other type of device.
It's cool. These boards are cool.
Exactly. And my suggestion is to take a look at the code lab. The code lab walks you through every individual step of creating your first smart device that you can control through Assistant.
Okay. So cool. Let's start coding this and actually see how the parts fit together and how the code is organized. Yeah, let's show the code. People are shaking without so many times without code. Let's see.
Perfect. So the way I've set this up today is using Firebase Cloud Functions.
Cool.
So I have here in my code here various functions that I've deployed that we use throughout the controlling aspect of this IoT device.
Okay, and you are using the Node.js client library, right? So
Exactly.
We already have a client library that supports all the interaction of the home automation, right?
Yes. So we have a actions on Google client library for Node.js. You can see here, I also have imported Firebase functions. And you can see also that I'm using Firebase admin for my persistence layer to store the various states of my device.
Okay, cool.
And so the biggest things that we need when developing for smart home, as we stated earlier, are those 4 fixed intents: the onSync, onQuery, onExecute, and onDisconnect.
Okay.
And so what I have here is the onSync. What this does is it provides a list of all the devices for a particular user on your service.
It's like Google querying for the status of your stuff,
Exactly.
your connected stuff.
Right. And so when you initially go in and say you just bought a new light bulb and you want to control it through Assistant, you have to go through this initial linking process, account linking.
Yeah. For
Right.
example, when I on Home Hub, when I just swipe to left and see all my home stuff connected, like light bulb, thermostat, it's querying all my devices, calling onSync method for onSync API for all my stuff connected and returning me the status, right? So something like that.
Right. Right.
Okay.
And so we see here that I have one device called a washer, and we have a specific device type of a washer as well.
Okay. Quick question.
Yeah.
So these types are defined in our documentation, right? So
Yes.
you can't just come up with a Neto device. I can come up with a new device and just add device there. It won't work, right? Because we want to have the traits. Exactly.
So you can mix and match traits on different device types, but you are correct that we have a fixed set of device types.
Okay.
The reason why we have these device types is that, for example, when you actually say a command, we show an icon of a washing machine, for example.
Okay.
Right. We use the context of the actual type of device in various ways in the HomeGraph.
Cool. Yeah.
And so you can see here, I have 5 different traits or 5 different capabilities of this device. So it can turn on and off. I can start and stop the various cycles. I have a run cycle. I have modes and I have toggles. And so those are the capabilities of the device, and I can mix and match. If I don't want it to be able to have the turbo toggle, for example, then I can remove that, and you can no longer use turbo.
For example, some feature you don't want to expose through the home automation, you can just don't have the trait. So
Exactly.
Yeah, like many door lockers, they don't have, for example, the unlock option, right? Because someone could say, "Hey, unlock the door," and can open and go into your house, so you can hide some traits that you think it's critical, for example, right?
That's it, exactly.
Cool.
So you can see here a little bit more about the attributes. So when we look at what modes, right? So when you look at modes, you're going to have a set of modes.
Okay.
In our case, I've set up 2 modes. There's a small load and a large load for a washing machine, right? And so this is what it looks like in our structured JSON response on how that's defined for giving it back to Google.
Okay, cool. So if I'm, for example, I'm defining I'm a specific brand and I have specific modes that I want to expose that. But then I launch a new feature, I launch a new washer, then I can add new traits, for example, or new modes. I can go here, update my own sync method, and I don't need to deploy anything to the Google Assistant. It's like it will be live available to test these new modes, for example, right?
So yeah, as long as you are developing in a private state, you can continually update your various traits and your device types and things like that on your devices, and it'll be able to reflect what on the device. Cool. You would still need to have some type of on-device logic to be able to know what ingest
of course,
that information.
Need to receive this at some point. Your server must communicate with your stuff at home and send the command to you. So the washer must have like a Wi-Fi board, and we must have gone through the setup of your washer, connect to your Wi-Fi and this kind of thing. So yeah, I imagine that we are talking only about the home stuff, right? The assistant stuff. But yes, just keep in mind if you are developing something, you should still work on the hardware side. We are not giving everything to you yet, but yeah, you need to set up the part of your own machine and your own device. Makes sense. Yeah,
and we do that on purpose because we know that developers want flexibility. We don't define a fixed approach on how your cloud service communicates and controls your devices.
Yeah, that makes sense.
And so you're right.
Cool. So this is the So when I said, for example, there's one question. You can say the door is locked, something like that. Or just to see the status when I open the on my assistant and see the status of my stuff, it's hitting this part, right? This method. In what other situations this method is used, for example?
So the sync, the actual response that's returned, is also used when you request a sync. So say
I can request specifically. I can request a sync, for example.
You can request one from your cloud service. So if a user already has 5 lights and they go out and purchase another light, they're going to have now a 6th light. And if they want to be able to control that 6th light in addition, then when they register it on your cloud service, it's ideal that your cloud service then alerts Google, hey, they've added another device. Will you sync with me?
Cool. And when I say, when you said turn on the washer, how it happened?
So what happens there is it actually goes through onto the onExecute intent.
Execute, okay.
And so this here is the execution intent of going through and looking at the various inputs of the command itself.
Okay.
And so I look for what exact command that it's doing. So on, off, start, stop, pause, unpause, set modes, or set toggles.
And commands that were defined in your on your own sync, for example, when you define when you define device, you define there what you are waiting for, right?
Exactly. And so when all of these you can see match to the traits that we've defined earlier, like you said.
Cool.
So the on-off matches. So this is devices.commands on-off matches that of traits on-off.
Okay. Cool.
And so each different trait has different commands that are associated with it.
Okay. Cool.
And so another important aspect when looking at this code is the onQuery, right? I can ask Google Assistant, is my washer running right now, right? Another great question is if you have a refrigerator, you can actually ask Google Assistant if your refrigerator is running, and you better go catch it. And so
that's a good question, yeah.
And so onQuery is the function that actually returns that state.
Okay. Nice.
And so you can see here it's getting which devices the user is asking about the state for.
Okay.
And then it's able to get that information and return it.
Cool.
Lastly, the final and fourth intent that I want to go over is the onDisconnect. So for onDisconnect, the disconnect intent is the one that shows when a user unlinks their account with Google Assistant.
Okay.
So think
remove one of these light bulbs, for example.
Right. They remove a light bulb and they maybe, or they no longer have their washing machine, and maybe they sell it and they no longer have it.
Okay.
And so that's what the onDisconnect is used for.
Okay.
And so the second part that I want to go over for this is the on-device logic that I have.
Yeah, cool.
So
because right now, for example, can you go to for example, on execute?
Yeah.
On the execute code. I'm seeing here that you are, for example, in this case, you are doing like Firebase and you are changing, updating a field, right? With on, and this is your logic.
Right.
And then I imagine, I suppose as a amateur maker, so you have something in your device that is connected to this database that will receive an update that this value changed and then can do the hardware logic. Something like that? Right.
That's correct.
Okay.
So you can see here my Firebase reference here. I have a specific field of the device ID that represents my washing machine.
Well, you don't want to turn off your neighborhood washer machine.
And then I have a child called on-off that I update the value of to the parameter that was given to me in this request.
And question, this was defined by you, for example, right? You are the hardware maker, you are the owner of this process, and you defined the structure. So if our viewers are, okay, but I don't use Firebase, I use MQTT to send messages from the function, no problem, right?
No problem at all.
It's here capturing this command from here and changing the status on the actual machine, on the actual hardware. There's no locking, no dependence of like having to use the Firebase for this case, right?
Correct. So
even though it can be like an external API, that the only other API and another service that you want to maybe isolate from the home stuff, you can have another call for the API, right?
Exactly.
Okay.
And so all of this, you can abstract away to any type of persistence layer, like you said.
Anytime.
You can use anything from GCP, for example, to store this information and query later.
Yeah, because sometimes, for example, I'm just imagine, right? Of course, use Firebase. It's a great tool, but maybe they already have something implemented. They already have an structure, like an infrastructure for these hardwares, and they want to implement. So you don't need to migrate to Firebase first to integrate your hardware. So if you already have a hardware, if you are looking to integrate home Google Assistant, the home automation, you can do it. You don't need to use Firebase, all this structure. So I think this is the message, right?
Right. So when we look at how the device ingests these various this database information,
okay,
let's take a look at that.
Sure.
So this is the information. This is the file that I have that it runs on the Raspberry Pi on this AIY kit, and you can see here a few things. One, I'm using Firebase Admin to as the way that I subscribe to various elements.
Look, this is not Node.js. I'm seeing.
Correct. Yeah. This is Python.
So I don't need even to make this use the same language, because it's not running on the Cloud Function, right?
Correct.
So this code would be running in the device.
That's right. And so this is everything that's running on device.
Nice.
So you could have anything. You could be running Java. You could be running Node.js. Any number of other languages.
Yeah.
And all doing the same thing of listening for different database changes.
So here you have the logic for your washer machine. So this is the point here. And part of this logic, of course, is read the state from the home automation, right?
Right. So the things that I'm controlling here is one, the color of the light on the button of this washing machine.
Okay.
And then the various initial states that I set of, it's currently off, it's not on turbo, it's not running, and it's currently paused. And so what we have here is the various listeners and what I do inside each of these listeners. I actually set up the listeners here. So I'm referencing various elements within my database.
Oh yeah.
So a good thing to take a look at here actually is let's hop over to here and look at the structure of my database.
Sure, cool.
So
this is how you organized the data for each device you have, right? This will reflect each washer. So if I imagine that this is the database that the brand owns, right? And we'll have like a one registry per person per linked to the account. Exactly.
Right.
So more or less, of course, they can change the architecture. They can have different authentication, but this register on the washer, it's specific for one hardware, right?
Yes. So because this is for a code lab, there's some hard coding done here to just one washer and one user, right? So this kind of goes as a MVP bare minimum of showing an example of how this would work.
Exactly.
And so I have here, I've expanded each element here to show what's inside. And so when I have from here a reference of washer on off on, what that's actually looking for is changing any changes to this field here.
Let's show this. Can you do the ask again to no not here. Say the command on your voice, on your phone.
Yeah.
To turn on. Let's see changing here on the database, so they can see how it's connected to each one.
And so what you'll see here is you'll see this, all of this change. You'll see there, some colors change here, and the value of on off to become true. Cool. You'll see this also flip to be on.
Yeah, quick question. What is this?
So this is, think of Philips Hue website or the Philips Hue mobile phone app. This is the Code Lab front end for controlling your washing machine.
Even if you don't have your device, physical device, you can check the status for this from this web page.
That's right.
And even if you're in a testing mode, you can write this for your own hardware and your own endpoint and check the status through this. So you don't need to actually have a hardware all the time with you, right?
Right.
This
exactly.
Is cool. Yeah, because it's reading the same data, right? So cool.
And so you'll see this change here. You'll see this change here, and then you'll also see in this terminal the actual device have an output of when it receives the command.
Oh, okay. It's like your debug window for the device.
Right. So this is I'm SSH'd into my Raspberry Pi here.
Cool.
So let's watch it happen.
Do the show.
Turn on my washer.
Okay, turning on the washer.
Oh, I see there. It's through here. This toggle there is on, and
it showed that it's turning on. So all three elements there in near real time is event based, to where based on your voice, it's doing all of these things.
So it's cool because you set the command. Google Assistant parsed the command, understood that was something to your washer, checking your home graph, say, yeah, he has a washer. Then call this webhook and with the onExecute, send the tray, the driver. You updated the database, and it was like immediately, like instantaneous. Right.
That's the beauty of all of this going. It's all event based. It happens so fast, and that's why I like doing IoT.
Yes, man, it's cool. Yeah, this is personally, it's something I really like. I'm able to spend the weekend connecting wires and trying to run random stuff. It's cool. So cool. I think we cover a lot of stuff here, right?
We did.
Can you just recap some steps that they have to keep in mind when developing this?
For sure. So from a high level, the big thing to remember is that this is cloud-to-cloud communication, where the developer responsibility is taking in a structured JSON response from Google, applying some logic to that of what state the device should do, okay. And then actually controlling the device.
Cool.
And so from our perspective here, the way we've set this up is that we're using Firebase Cloud Functions for the various intents that we're listening for.
Okay.
And then we're using Firebase as the persistence layer to store the device state. And then the Python application that's running on the Raspberry Pi listens for those various states.
Cool. Yeah, this is so cool. I'm very excited because I like this stuff. I like IoT stuff. So yes, thanks for being here. Thanks for sharing this amazing. I think if they want to find us, they can reach us through our team's Twitter handle, right? Actions on Google. And if you're sharing something with us, also use the hashtag AOGDevs so we can see your cool stuff, or if you're making a question to us, it would be great. And also, we have the Reddit Actions on Google, so you can ask questions, meet other people from the community, right? And if you have a question where they can go for technical questions,
Stack Overflow.
So Actions on Google would be great, right? And thanks for watching. Please give your comment, your feedback, what you think, what the next episodes you are waiting for, and we will be glad to produce for you, okay? See you next time.
Thanks.